See if it works. Check, check. Check, check. Check, check, check. Niin jo. Saaks sitä tästä? Check, check, check. 1 2 1 2 1 2. Hop 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 hop.
Se niinku päällä.
Ai, tommola.
Hop hop. Onks tääkään päällä?
Se mun mielestä kuuluu kyllä.
Kyllä jotain kuuluu. Ei kun kato mikrofonit. Noniin.
Noniin.
Mä olin väärässä paikalla. Audio on nyt ihan vittu täysillä. Eli se on tää. Ootas nyt. Höp höp. Noniin. Now we're talking. Alright.
Eikä se oo hyvä.
Hyvä se on. And you can put whatever slide you want in there.
Yeah.
I just put it on the first one.
Yes.
Cool. And we have on Sihan's computer our slides, so I'm gonna talk like a minute or two about it.
Yeah, absolutely.
Okay, great. Cool.
I just pressed up.
Oh, okay, very good. So you see that in Tampere different people are coming in time, and all the people that have signed up are coming.
That's nice. Well, then I have
I trust in her.
right, yeah.
I trust in her, Carol.
We'll see. You will have, more people are getting there.
But last time she was late as well, so
Yeah.
when she came. Okay, there is the other. He's running the other GDG group.
Ah, you can introduce me to him.
Yeah.
Yeah.
So also there is one guy who's running the API days in Helsinki, like small size
Yeah.
conference. So he might be also a good like
Yeah,
contact to
yeah,
ask
yeah.
like how to organize these things.
Yeah, we have the mic on the other mic.
Oh, cool.
Also, this mic is the handheld.
Maybe I'll use that one.
Yeah. It's on the. Turn it on first.
Yeah.
From there. Let me.
Oh,
So you have still, you still wait a few minutes.
Oh, it's on it. Up, up. up it a little bit.
Hi. Perfect. Yes. And the stream is already up.
It should be up.
Okay. Perfect. I guess we can just start.
Sure.
Those who come later will
Thanks.
miss this first thing. Okay. Hi everyone, and welcome to the third meetup in Tampere. It's nice to see all of you here, and this community growing and thriving. So today's agenda is as follows. You might have seen this already in the meetup page. We just announced it. First, we're going to talk a bit about the Cloud Native Nordics community and the meetup groups that are here in the different places in the Nordic countries. Then we're having an end user talk by Sergey from Stora Enso about how to run stuff on AKS, Azure Container Service, Kubernetes Service. After that, we think the food will arrive, and at 6 p.m. And a bit after that, we have Carol Chen from Red Hat talking about how she thought KubeCon was. That was recently in Barcelona with 8,000 around attendees. It was a nice event. And last, we have Jihan, yeah. Sorry. From Futurize talking about serverless. So exciting times. Lastly, we hope to have some time for networking too. We're glad to be here at Futurize, and they're sponsoring the food, the drinks, the venue that you are in. Well, really nice to have that. And they're going to introduce themselves just after this. We want to start with some meta topics about the community and how we try to build a stronger participation in the cloud native communities worldwide through local events and meetup groups. First of all, we like to get to know you, and what companies are you from, what are your interests, and what brings you here. So we're gonna do some surveys, and we have this thing that we call the meetup company landscape. So we can a bit understand what kind of companies or employees from which companies are attending these events. So if you're, I'm gonna show what the landscape looks like. But if you want to be there, have your company being named there, go click that link. We're gonna share it afterwards too. So this is our 12th event in Finland. We have had 9 events in Helsinki for around soon 2 years. And as said, this is the 3rd event. And through this process, we've got a lot of different companies participating. These are the ones that either have sponsored the venue or provided speakers. And I think this is nice to see and gives you some kind of pictures of who's doing stuff, who's interested in this. And we're always also looking for sponsors. So if you want to help out with speaking, that is something we really want and need. Or if you want to sponsor, reach out to Oliver or myself. But the meetup company landscape that I just talked about, although you have not spoken at an event or sponsored the group, we're also just, we want to know the companies that are using Kubernetes and similar in the space, and here we have a couple of those in Finland. I don't know, do you have anything to add about that? Yeah. Right. And then some months ago, we started thinking about what can we do to bring the meetup groups in the Nordic countries, there are about 10, closer to each other and share some experiences and also share patterns of how to do things and also stuff like sharing speakers. For example, in the Helsinki meetup, we had, not yesterday, but Tuesday, we had, through this community, we had a speaker from Gothenburg, Jessica Andersson. And she flew from Sweden this Tuesday, delivered a talk at our local meetup and flew back. That was really nice. Nice to see, to get going, and we want to increase that kind of, get different perspectives from different places through also moving people and making this all more dynamic. So we're gathering, we just got some really nice logos from your friend Andre, and we're going to get to making t-shirts of these, but most importantly, we have a Slack channel where I encourage you to join. It's under cloudnativenordics.com. You can sign up for the Slack and find it. Also, we're planning on making a website aggregating all the Nordic materials. So all the slides that have been presented at Nordic meetups, all the speakers that there have been, all the different events, all the companies that have been sponsoring all the 10 different meetups in the Nordic countries, etc., etc., etc. Yes, I mentioned this, the t-shirts. We're figuring out how to deliver these and what way to get them sponsored. But if you're interested in getting this kind of t-shirt, watch the, we'll just send out some kind of question or announcement to the mailing list in the meetup group. So if you're interested, watch out for that. Or if you want to sponsor, we somehow need, it costs money to create these t-shirts. You can reach out to us too.
Any plans of making socks?
Socks? We could do that too. Do you want? That is a good thing. Do you want to sponsor the socks?
I can have one.
Yeah, we're not limited to anything with this kind of thing. So yes, we can do socks. Yeah.
So we might do socks.
Maybe we should do socks.
It's cheaper outside.
Yeah. Yep. And finally, if you want to speak, one of the hard parts of organizing a meetup is actually also at this stage is getting speakers. And I generally think that there's maybe the perception is that you have to build a thing that takes you to the moon in order to stand up and say what you've been doing in this space. So we hope that we can a bit lower that kind of expectation and make it easier to come here, say, we've done this thing in with Kubernetes or with any CNCF project, and yes, we failed with this thing, 3 things. But we also learned these 5 things that you might not have thought about because they were really thorny, because it's a new technology. So it didn't work as expected. And now you also can take part of that knowledge. So yes, if you're interested in speaking and telling your story at your company, or how you have been experimenting with different stuff, or just 5-10 minute intro on a project, like what is Harbor, what is Linkerd, what is something. And then we have a Google form for that. And if you're not ready to speak now, but say maybe in 3 months, then I would encourage you to join the Cloud Native Nordics speakers Google group or mailing list that I just created. I literally created it like 10 minutes ago, so no, that's only me there in there. It's nothing strange with that, but I hope you come and join it so we can start posting announcements there. Across all the Nordic countries. So there you also can get invited to come and speak at Aarhus in Denmark, for example. And finally, we're gonna start a meetup in Turku later this year. So if you have friends there, let them know that this is coming. Let them know that. No problem, no problem. Let them know that they can help out, they can speak, they can sponsor, that this is ongoing. If you want to watch old recordings, we have a YouTube channel. We're also streaming to that at the moment. We have a Twitter account like that, for example, when you tweet, which I hope you do. And other things. There's a Slack channel in the Kubernetes Slack where there's 65,000 others. You can join FI users, or as said, the Cloud Native Nordic Slack. If you want to see the different meetups that are existent in the different meetup groups across the Nordic countries, we have a GitHub repo for that. Any other things that we missed?
No, maybe not, but I would like to really encourage you to join the Cloud Native Nordics Slack channel. You can very easily contact me and Lucas and all the others that are active. So it's a very, and you can very easily keep up what is actually going on. Where are the events, other events than in Tampere. And so it's really welcoming community. So I really encourage you to join.
With no further ado, let's.
I have a question.
Yes.
Is the Slack.ks.io the same as Kubernetes or Slack.io?
Yes. So the Slack Kubernetes.io is yes. That's the general Kubernetes Slack for worldwide with 65,000 or more people. But the Cloud Native Nordic Slack is our own in these countries, which unfortunately doesn't have 65,000 members yet, but we're getting there. But yes, are you doing the Futurist intro? Yeah, cool.
Yeah, hello from my part also. While Sihan brings the presentation I'm supposed to give, first of all, welcome to our office. Some practicalities first. The toilets are over there where the wardrobe is. The fridge is cold. Grab a drink from there if you want to. There's some alcoholic and non-alcoholic ones. The food should be arriving at 6. And the only thing that I ask from you is if when you finish your drink, please put the bottle or the can empty. Like if you have something, just pour it out first. And put it in one of these metal bins that we have around at the kitchen there. Thanks. And I won't bore you too much with the details, but here's a small presentation about what Futurist is. First about myself, my name is Tomi Turtiainen. I've been at Futurist for 3.5 years now. I'm a full stack developer / architect / tech lead. Also do some recruitment. We're also hiring like everyone else. So if you're gonna learn more, just pull my sleeve and we can talk today. So what is Futurist as a company? We're founded in 2000 in Helsinki, Finland. We have offices all around Europe, in few in Germany, latest in Stuttgart, opened recently, London, Stockholm, Oslo. A bit over 550 employees, 40 nationalities. Oh yeah, and we are actually a family of companies. So Futurist is the group, but we also have some startups like Columbia Road and Aito.ai that focuses on AI and stuff like that. And I don't know, some of you might have noticed we had our whole company in Tampere last week, and we had our summer party, which we do every year. And we were in Viikinsaari for the party, and then in Hiedanranta we had a seminar there on Friday. And what we basically do is we want to be builders, innovators, and change agents. So we want to help show the world how to go digital and help our customers and clients in that. We use a lot of tools. We do like a lot of tech, but we also have a lot of design and advisory and data science as well. We have developed this lean service creation model in-house that we use quite a lot in our projects. We have customers like from all around the world, big German and Finnish companies. In Tampere, our office is called Tammerfors, and we are plus 70 people at the moment here. And culture is our DNA, and it means a lot to us. And it's built on our 4 core values, where first is trust, which means that it's given, and you don't need to earn it first. And it shows, for example, that everybody gets a company credit card and can decide on themselves when to use it. We are transparent. All our numbers are visible for our employees, and we appreciate continuous improvement. We have a lot of learning in-house. We pay our employees if they do cloud certifications, for example. We pay if our employees want to do some open source projects on their free time, get 15 euros per hour for that. And we care a lot about our employees also, so yeah. Go check out futurist.com or ask me if you want to know more. Okay, let's get this party started.
You can do the first one? What? Are you the first presenter or?
No.
Okay.
We have. Or are you doing the? Did you have something different?
Who's the first presenter? Does anyone know?
Sergey.
It's Sergey. Yeah.
Yes.
Okay, sure.
AKS.
Thanks.
Thanks. His presentation.
Okay.
It's AKS.
Will you give me the microphone?
Yeah, you can.
HDMI?
Yes, HDMI.
There you go. You can use this, it's probably a lot easier.
Yes. When having a longer talk.
Yeah.
You need to teach me how to use it.
Just put it on and then speak. And you can put this
All right.
in your pocket or like
No, let's try.
plug it in.
Check. Can you? Yes. Looks like you can hear me pretty well. So I will just put it to my pocket. First of all, thank you for organizing this event. And second of all, thank you that this is going to be held in English, because Finnish is still way difficult. Suomi on tosi vaikea kieli. Every day, joka päivä, when I try to speak, it's pretty much struggling. It's pretty much ikävä kokemus for me. It's I'm trying hard, but still. When I came to Finland, I had this book with me that kind of a common phrases and common questions that you can ask, how to come to the main square, how to reach the post office. But then I realized pretty fast that I can ask questions, yes, but when people respond to me, I don't understand anything. So that's why I'm so quite happy to have this thing still in English. So on the next slide, I will introduce myself. What am I doing, and who am I here in Finland? But as you see from the first slide, that the main topic of this day for me would be the managed Kubernetes cluster in Microsoft Azure. And raise your hands who knows the Microsoft Azure or who has any experience with the Microsoft Azure. Okay, so anyone from Amazon Cloud? Okay, so pretty much same people. But I hope that if you raise your hands that you know what is Kubernetes, so we don't have to go to details. So that's good. Yeah, so the main part would be, of course, the demo. We will go to Azure portal, try to set up the cluster. Well, I did set up a cluster because it takes about 15 minutes to set up. So I will show the steps, but then I will click cancel. So we have already one set up for this demo. And then we would deploy the Express API there. But let's move to introduction. Who am I and what am I doing at Finland? So my name is Sergei Sedelnikov, and originally I came from Russian Far East, settled down in Finland some years ago, and joined a company called Stora Enso, which is heavy manufacturing company. We are producing things like paper, biomaterials, wood products, packaging solutions, and so on. The total amount of employees all over the world is about 27,000. In Finland, we have several offices. Main office is in Helsinki, and in Tampere, we have this so-called intelligent packaging division by Stora Enso. We are here in Tampere developing solutions for tracking the packages. So with RFID, radio frequency identifiers. So we are responsible for keeping that track and trace 360 visibility for our customers, so they can log in, see where is their order. If they ordered 5 tons of pulp, 6 tons of paper, they probably want to track how it goes. And we are here doing that system called intelligent packaging. So mostly I am focused on cloud computing, logistics and IoT projects as a solution architect. And most of my work since 2011 related to Azure cloud. I've tried some Google Cloud, IBM, Bluemix, Amazon Cloud, but because of some reasons, Stora Enso decided that we will use Microsoft offer as a main public cloud provider. And recently we started to use Kubernetes clusters in the cloud. And as you may know that there are 2 options that you can have a cluster, either unmanage it or manage it. If you decide to deploy the cluster yourself on your own hardware at the office, this is so-called unmanaged cluster. So I hope all of you know, do we have here any laser? I believe there's no laser, but I will then show. So if you can see my cursor here. So the first picture on the top shows the architecture of unmanaged cluster, that you have so-called Kubernetes master that runs the engine itself, plus you have the API. On top of this API, you have web UI and CLI. So you can make a commands to your master. And then, of course, you run the so-called worker nodes that really runs your Docker containers, your applications. And then at the bottom of the page, you can see so-called managed Kubernetes, which is offered by Azure Cloud, Amazon, Google Cloud, and I suppose that also other cloud providers, they are moving towards that direction to offer so-called managed instance, where you have only worry about your own working nodes, but they will manage for you the Kubernetes itself. They will make sure that this virtual machine that runs it always up. They will give you API access, some certificates, so you can call the CLI, and so on, so on. So it looks like this dream world or Mummivali, that you have this everything managed for you, no problems whatsoever. You only worry about what you run. But of course, with every solution there are pluses and minuses. And if I would be the Microsoft sales guy, I would strongly push you that the down picture below as a kind of the best ever option for you, without mentioning any of the negative sides. But there are some negative sides and positive sides. So if you take a look at the list, the unmanaged cluster that you have to manage everything yourself. You need to set it up. You need to keep it running. The positive side for this is that you can have a hybrid architecture there. So you can run the master on premise, run the virtual machines with your working nodes in the cloud. It also could be a multi-cloud option. You can run some nodes on Amazon Cloud, some nodes can be running on Azure Cloud or whatever. But you need to pay a lot attention on security yourself. So basically, you need to secure your cluster yourself, all the API access, all the certificates. And it's kind of a one-time investment. If you have your own hardware in your office or in a server rooms or whatever, so you pay for the machines once, then you have them running non-stop. So it could be that you spend like 10,000 euros or dollars buying the big server cluster, run it in your office, and then you're happy. You have a DevOps team who is managing this. It's kind of one-time investments. And I know the companies who are doing that approach only. So they don't rely on cloud. They just buy the hardware, set it up in the office, and it runs without any issues for years, basically. And if you compare it to the managed approach, that it could be the problem if you want to purchase the cluster from Azure. Pretty much you then limited to only using Azure network capabilities. There are ways how you can set up a hybrid networks. There are ways how you can connect your own machines to the cluster. But again, and actually Azure quite good in that hybrid approach. But if you have some other cloud providers, that could be the issue that you pretty much limited then running the cluster only in the public cloud of your choice. You don't pay any, what is a good side that if you purchase this managed Azure Kubernetes cluster, you don't have to pay for managing it. It comes for free. So Microsoft and Google Clouds, they don't charge you for cluster itself. You only pay for virtual machines that you use as a worker nodes. So that comes with zero price. So they will manage for you. They will make sure that it runs. They will update the operating systems for you there, all the security patches. They will even update the Kubernetes version when it comes. You don't have to worry about those things. And it was actually a surprise for me, but that Amazon Cloud charges 20 dollar cents per hour, which comes to almost $150 per month for keeping the Kubernetes cluster up and running, just the cluster itself without any worker nodes. And you see here, this here is not the 80, it's my emotion that I put here, big eyes and big mouth, that I was really surprised that it runs like this. For some, maybe a year ago, maybe even less, Azure also charged that price, similar price for Kubernetes cluster, only the managed cluster, so-called Kubernetes master. But then they decided that they will not do it because that it's going to be quite expensive to start. And actually, it was one of the decisions to use Kubernetes in the cloud because it was so easy to start. We didn't want to set it up ourselves. We just want to click the button and get it up and running. But again, in managed Kubernetes cluster, what you do is you pay for every additional virtual machine you buy as a worker node. And the price of course varies. It's roughly like 100 euros per month. You pay for 3.5 gigabyte of, no, actually it's 7 gigabyte of RAM memory plus some couple of cores. It's roughly 100 euros per month. So we now have 2 nodes running, pretty small cluster, but still we pay like around 150 euros per month for those worker nodes, which is still okay because our system that we run in Kubernetes is quite small. And I will show what exactly we are running after these slides. So as I said, if you have quite big systems that would require you dozens of these worker nodes or even 50, 60 worker nodes, if you have hundreds of APIs, hundreds of workers running there constantly, so that could be quite pricey. And I know the companies, I don't remember the name, but they're quite big companies who are using these Amazon clusters. They could pay around 40,000 euros per month only to keep their infrastructure running in the cloud. Not only Kubernetes, but all the other application gateways, static IP addresses, so on, so on. So the price to keep in your hardware in the cloud, which basically you pay for the hardware, you pay for the salary of the people who are dealing with the actual physical servers there, that could easily lead to dozens of thousands euros per month. So that money definitely need to pay it back. You cannot just do it for fun. You need to, if you really have a need to set it up in the cloud, you need to calculate how much your software will bring you the money versus how much you will spend. So those operational costs, as I showed on the previous slide, this one-time investment, known issues with the money. I know the company in Finland who is developing software for some Facebook commercial engine that they can inject some commercials into Facebook, Instagram, with generated pictures for your products. They were thinking to run everything in the cloud, but then when they start calculating the prices, setting up things, really scale up the services up to 1 million transactions per hour or per day, they quickly came into conclusion that paying for cloud is like killing the business. So they decided to make this one-time investment, bought the hardware, spend 10,000 euros, get a team of hardware engineers or technicians who will handle that process, who will handle the server box. And they still keep all the system running on premise, and they save a lot of money just because of their decision, so they don't go to cloud. So you need to calculate. But again, with the second approach, it's really easy to start. You basically can start with 0 euros, scale up to 100 euros per month, then scale up to 300 euros per month when your business grows, when your needs are growing. And then when you cross the point, when you no more can afford to buy cloud powers because you don't get enough money from the income from your software, then you need to decide, do you really want to continue in the cloud, or do you really need to set up something yourself in your premise? Or make some hybrid approach. So part of the hardware will run on premise, that is relatively cheap, one-time investment, and infrastructure like public IP addresses, API gateways, so on, can be in the cloud. So those two approaches are visible.
May I add one small comment?
Yeah.
Today, yes, Google has a standard tier, which is free, but they also start adding features which are so-called enterprise. So now you have two ways of doing it. One is the free tier if you have basic needs, but then you start paying like AWS if you want the more advanced, they call it G-key advanced. So that's one, but also there was one other thing which I forgot. Anyway.
Okay, yeah. So the next slide, and I only have this slide and the next slide maybe, and then we will go to demo. This slide shows, and I want to tell you why we picked up the Kubernetes as a managed cluster in Azure to start. I already explained about that cost of start is it's almost nothing. So you don't pay to start, but when you start, you need to grow and then check your cross points. So in intelligent packaging, we are now starting the project that you see on the right side of the picture, which is kind of a vending machines with RFID radio frequency identifiers that you have goods like snacks or drinks or whatever. Nowadays it's a pilots. You will not see it in Tampere or Finland. It's just the pilots for now. So you see this. You scan the QR code with these payment systems. I won't tell you the name, but there's a payment system which is used in Prisma in Finland or in some other similar shops that we can pay with. So there's a QR code on screen. You scan the QR code, door is unlocked. You pick up your drink or your snacks. Each product has this sticker, which is basically radio frequency identifier, and each shelf has the antenna. It reads through the cabinet, through the fridge. Close the door. It checks what is now missing, and then sends you the payment request for your phone, and then you pay. And basically for this cloud communication, of course it's connected to internet, and all of this cloud communication between payment systems, between the refrigerator itself, is deployed to Kubernetes cluster in Azure. Why we did pick up the Kubernetes? Why we didn't pick up why we didn't just deploy the code like Node.js API or C# API or whatever? So we wanted to try something new, and before even joining this Kubernetes cluster movement or thinking, we had already our code running in Docker containers, but it was just deployed on a plain Docker. So server, then the Docker engine, and then the containers running there. So the second reason was that finally Microsoft released this Azure Kubernetes service, which was quite easy to start. Before that, you have to select what what Docker container engine you would like to run in the cloud. You have to set up some configurations there, but now it's just click, 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 and then you get the cluster running. So it was easy to start. For now, we are not running hundreds of containers there. Maybe we have 10 different containers, some for API access, some for transaction checks, some for digital twins for refrigerators. So it's still manageable with a couple of 3-4 nodes. It's pretty cheap to run the whole system. And in the future, we plan to migrate all of our solutions that we're now deploying as a plain code, as a libs or as a libraries, C#, DLLs, or Node.js packages to Kubernetes, to Docker. Still have some old legacy systems that runs as a plain code in servers. So if you take a look at the architecture, how it looks like, so we have those edge devices, which just stay on premises next to some physical device that could stay here or could stay in our office. They have the 4G connection to the internet, and then they are communicating with API through this DNS. Of course, the application gateway, and then of course there's a DNS name behind it. So the application gateway in Azure is a special service that basically makes sure that there is a firewall on, there is no DDoS attacks, there is some smart routing you can set up, and also you can kind of provide the SSL encryption through the gateway. So you don't have to have any ingression control on Kubernetes cluster itself. You can just deploy it as load balanced, and then you can set up the. So API has a public IP address. It deployed as a load balancer service, and then the public IP address is connected to application gateway, which is a separate Azure service that costs around 50-60 euros per month for basic tier. And then, of course, DNS name. So that's the pretty much communication, how we use the Kubernetes cluster, and the digital twins for each of the device. So basically, amount of devices should equal to amount of digital twins. So they have the settings, payment provider options, the identifiers for some banking systems. So each of them has its own settings. And when we create a new device physically, we instantiate the new digital twin there. So and set up some settings. So this is the POS terminal number 5. Use the credit cards like these, use this kind of payment systems through mobile, and all of these registrations happening in digital twins. And the API communicates with digital twins through the thing called NUTS. It's more like messaging. So they're in the same cluster, but they communicate. So API can ask digital twin, give me your current status, and Kubernetes receives it through this chain of communications. Do I have anything else here? So in the demonstration I'm going to show you, we will set up the cluster itself. We would set up the public IP address for that. We would set up the application gateway, and then we will make sure that that public IP address that's generated by Kubernetes, or we created it manually, it would be protected. So the customers or devices which are accessing this API can only access it through gateway, not through the public IP address, which is unprotected, unencrypted. There is no SSL, there is nothing. So that was my 15 minutes of slides, and I created here the GitHub repository that contains the deployment file, the README. I tried to put everything into README, how to set up protection, how to set up the application gateway, what is what in Azure. And basically, I already showed you, already told you the content of the demo. So we will now have the API deployed to Kubernetes. through Azure, and without any delay. Yeah. Yep.
Did you ever evaluate usage of the container services, like as a migration step before the networking? Because we don't have so many containers.
Yep.
So it's like how you
Well, I must say that most of our kind of okay, this new retail is pretty new business for us. We're just entering, so we basically started from scratch, and we made it with Kubernetes already from the first try. Before that, we had the business related to logistics, tracking through the from some factory to factory. They have some kind of RFID readers that they would read the content leaving the factory, content entering new place. So we had so-called edge servers that are not in the cloud. That because of all the factories, they're quite closed from the infrastructure point of view, so we cannot connect to internet, some internal network. So we had to set up servers there, and on the servers, which been allocated for us on each factory, on each of our customers, we have already kind of a piece of software which we call kind of a server. Of course, the internal name is different, but it's a server that just runs in Docker as just a server. So maybe we will migrate those, or maybe we will start for the next customer first setting up on the physical server the Kubernetes, and then on top of this we would set up the containers, not on the plain Dockers, but
I wasn't asking about that one.
yeah.
The question was like there is Azure Container Services, which gives you possibility to have a Docker container.
We are using Azure Container Instances for that. We have them. Yes, we have them used for other approaches like MQTT brokers to real-time messaging through the cloud. But what you refer to Azure Container Services, I think you cannot instantiate it anymore. It was that you create Azure Container Service, and then you check what would you like to have. Kubernetes, was it like DSOS? Was it?
Yeah, most probably it's like container instances that I was
Yeah,
like talking.
yeah.
It's like a step between
Yeah.
that. It's kind of
We
you don't really need to-
we were using them for different approach, but if I go back in slide, most of the problem comes when you need to instantiate multiple containers in the same cluster, because they need to talk to each other through Redis cache, through NATS messaging, or through some other API. That's much easier to do with Kubernetes cluster as its own, because it has its own network. But at least I never tried myself to set up container instance that would run 2, 3, 5 containers at the same time. We only use them to run only one container at a time. So basically, it's a little bit different architecture here, and I think I wouldn't try even to put like one API container, then try to communicate with totally different digital twin containers. They have their own public IP addresses, because those digital twins, they are not exposed to outside world. They're only inside of clusters, so we cannot access them publicly through IP address. And I must say that I don't think we had a plan to try something not protected by Kubernetes ecosystem. But we use container instances for different standalone kind of messaging systems. And actually, I did mention that there is a live messaging through Socket I/O from API to physical devices. So when user scans the QR code and authenticate himself or herself in payment system, digital twin sends the message through the Socket I/O API that now there's a user comes, unlock the door, and so that's the not only pooling or pushing data. There's only also Socket I/O. Socket I/O deployed to API that would notify the device to unlock the door. But let's go to demo. And so my demo wouldn't be related to anything about the refrigerators, but I prepared in my Azure. How many minutes do I have here? 10 minutes. Okay. So I prepared here in Azure the Kubernetes Meetup resource group, and I already created a Kubernetes demo cluster plus the application gateway to access this. But let's now try to, I will just show you how it looks like to create a Kubernetes cluster. So AKS, which means that Kubernetes service. You select it from the list of available services in Azure. You click Create. You select the subscription. For those who are familiar with the Azure, it's pretty straightforward to select the resource group. You name it, like test Tampere Kubernetes 1. It checks that name is okay. You select the data center where to deploy. Let's deploy it, let's say, to, I don't know, West US. It doesn't matter, but it's just that you select the version, some default versions, stable versions, and preview versions. And then you pretty much apply DNS name prefix. So it will be that kind of, if it would be Ingress API, that's going to be the DNS name prefix for that. It's by default, it equals to the name -DNS. Then you set up a scale. We don't use virtual nodes. We only use the physical virtual machine. Well, yeah, physical virtual machines. It's kind of a standalone virtual machines. The authentication can go to default. By default, it's a server principal. You get a certificate to connect to it, and you use kubecontrol CLI to get a certificate from Azure. It's saved to your local machine, and then you can execute kubecontrol. But you can apply more settings here if you want. Networking stays like this, and if you notice that it has a built-in option to give you the kind of HTTP routing, but it's only recommended to use it for development and testing if you enable it. By default, it should be disabled. And when you set up API, you open up the public IP address only for your API, and then you protect it with application gateway. That's how normally it works. Then you can set up the logging storage, the service which is called Azure log service. That Kubernetes with all the output consoles you have in your console outputs you have in your system, they would be saved there, and then you can search through all the logs. Some tags, which basically just meaning that you can search it through all of your Azure. I don't use tags here because we have only one cluster, but you could have it like customer, I don't know, futurice, deployment, some kind of tags, just a key value first that would simplify your search. Then if you have hundreds of different resources, it would be easier to search. So then you review that everything is okay. And you see by default it creates a three nodes here, 3 worker nodes. But for demonstration, I created only with 1 node, and I think on the scaling tab, it was the option that we could scale down the how many nodes do we want to have by default. By default, it's 3, so it's make sure that it's kind of 99.99 SLA. And if I would now click create, it will start creating those virtual machines. It will start creating the cluster itself. It might take about 15 minutes to instantiate the whole thing, but I wouldn't do it. So I would just go back to my kubecontrol. Basically, this is what you will get after the propagation is over. So it took me about 2 minutes to go through all steps, decide the necessary settings for Kubernetes, and then after clicking create, it would take next 15 minutes to get it ready. So after that point, you already have the cluster, and you can run your. You can call it with API. You can call it with whatever methods you want. Let me now leave the full screen mode, and let me now run the command line here. So I already got my Kubernetes certificate downloaded to my computer. But if you take a look at README, how then, let's say next step is to call API, like get the services, deploy service, check that everything is okay or not okay. So what we need to do now is that I prepared here plenty of text. You can read it in GitHub. But no, here. So first, to get the certificate, like download it to your computer, and so we can use the kubecontrol CLI, you need to execute that command like Azure, and of course you need to have the Azure CLI installed, which is pretty much described in documentation how to do it. Azure, then Azure Kubernetes service, get credentials, and then you specify the group name, where you create it, and the name of the Kubernetes cluster. And then if I call it here, it basically would then download those to me, and basically it will kind of allow me then to use kubecontrol. Sometimes it takes time because it needs to check that I am logged in into Azure CLI. I have all necessary traffic, all necessary certificates and kind of tokens and cookies, etc., etc. Yes. Now it says that it downloaded them and saved to my kubeconfig file. And if I now go to kubecontrol get services, that will give me the services from that. Pretty much there is no services at all because it's empty. I just created it for this demo. But let me do so. I will copy the path. Yeah, it takes time. Usually it doesn't take time, but now it takes time. It's a demo effect. But believe me, there is no services. There is also a way how you can tunnel the Kubernetes web console to your local host. There is a command, Azure AKS browse, and then you specify what cluster you want to browse. But somehow I did some mistake in configuration, so it doesn't allow me to browse. It just shows me that you cannot do it, but maybe you will get more luck. So you see now it returned the list of services here, which is only this one main Kubernetes service. And now I navigate to this API folder I prepared, and I have here the deployment file that would pull the image I prepared beforehand, which only have standard Node.js Express API with the root endpoint only that says hello world. So if I would now apply kubecontrol apply file deployment.yaml, and you see I'm doing it in real life, so I'm really risky here because if it fails, then there is no demo. Oh, so basically now it created this, it applied the file, and if I get the services again, it should give me the, and you see now, yeah, one thing, you see now that I made a mistake here because I already specified a load balancer IP here, but we haven't yet created this. Because what I wanted to demonstrate is that if you specify the service with the load balancer type, the Kubernetes in Azure would allocate public IP address for that, and it would map it to cluster AP internal network, and then it would be possible to access the API from the outside world through this IP address. And I already a little bit highlighted that, so you can create static IP address in Azure, which costs about €3 per month to host it, but it's much better than allocate dynamic, because by default it would be created and you are not in control of it. You probably want to get control over the IP address that is created for you. Because if cluster is destroyed, it wouldn't be possible to get the same IP address if it's not static. So let me now delete this line and deploy one more time. Yeah. So we will get that kind of we will allow to Azure to generate us. First step, I will show how it generates dynamic IP address. Then I would show how you protect it, so how you make it static, and then protect with application gateway, and then the demo is over. So if I now get the services again, by the way, I think you cannot see this. Maybe if I need to make it bigger. How can I make it bigger? No? Cursor size. Who is here? Those specialists here. Oops. Yeah, now it's much better. So you see here, we get this. Okay, now you don't see. Can you see here? No. Oh, yeah. Here, yeah. So here you see we get this API demo service created in the cluster. And you see that it has the cluster IP address, which is, of course, within the cluster internal network. But then the external IP address says pending, because now Azure creates this static IP address in this data center, maps it to Kubernetes cluster internal network, maps the ports 80 to 80, and then after 1 or 2 minutes, it should be created. Let's pull it again. Yeah, no, it's still pending. So it should be created, and then we would be able to get that API online. Let me a little bit show you more. Here. So this is the internal resource group that when you create a cluster, it creates you that resource group with the so-called agent pool, AKS agent pool, which basically a collection of your worker nodes is here. You don't need to really touch it. You only need to scale up, add more nodes, or add less nodes according to your needs, but you still see those. And here at the bottom of this, you see that the public IP address resource. For those who knows Azure, they probably saw it before, but for those who doesn't know the Azure, so it creates for our API, when you see pending, it means that it creates still this public IP address instantiating. And here's a load balancer, which is created again for this API. So if we take a look here, it should be already created, and we have this IP address here, which basically was allocated for us. Do we have it here now already? Should be the same as you see in Azure portal. Yeah, now it's there. So you see that the external IP was allocated, the provisioning of that resource was finished, and if we are copy this and go to navigate to it, it says that hello world. Basically, it works. But the problem here that it's kind of dynamic, and every time we kill the service and create okay, for some reason we need to kill the service and create it again. If we kill it, it will kill the public IP address, and probably all of our DNS names would be broken. We probably would have delay until the new DNS records would be propagated all over the world. We got the devices not running, we got money loss, etc., etc. So as an architect, I would be happy to control what's happening there. So there is also a way how you can create the IP address as a static, and then when you tell to Kubernetes instantiate that service as a load balancer with that IP address, then it will use that IP address resource exactly. So if I now copy here, I already prepared the line I need to execute. I will push it here to console. Oops. So what it tells that Azure network service create me public IP address within this Kubernetes internal resource group, because how it works in Azure, so if you create resource in the same resource group, they would be allocated as close physically to each other as possible, and they would get kind of trust to each other, because resource group in Azure doesn't just a logical folder that kind of specifies the scope. It's actually a physical thing that they would create in data center. They would create those things physically as close to each other as possible. Create the IP address, name it like Kubernetes Meetup demo ingress IP, and make it static. Basically, if I click it like this, and I hope again it will work. If not, then we will just use the portal. It might take about a minute or two to instantiate. Meanwhile, yes, now it instantiated, and you see that this is the IP address that was allocated for our service. Not for our service, but that was allocated for us. I copy it, and basically here in deployment, what I need to do is I need to specify it here. Then it would tell to Kubernetes that no matter what, if service is deleted, if Kubernetes is rebooted or even deleted, that static IP address is something that I control as a developer or somebody else control as an owner, as an architect. This one never should be deleted, and please load balance this API and make sure that this is the ingress API for the ingress IP address for that API. But I pretty much believe that if I will then run it like this. I will first apply, because I remember when I was make a rehearsal at home, I had to delete the service, so it would kind of unbind the previous public IP address and then bind the new one. But let's check. Let's check that if I get these, if I scroll up so you can see it also. If I now pull the get services. So what should happen now is that the old public IP address, which was dynamically allocated, should be deleted, and the new one that we are in charge of should stay, and it should be connected to API. If not, then we would delete the service, and then we would instantiate it. But meanwhile, let's refresh it. So this one is already not running, so that's kind of was killed already. And if I now paste the new one here, it's still propagating, so yeah. Meanwhile, if I go back to the main Kubernetes Meetup resource group, let me show you. Here, this is our IP address that we are now created. And basically, what you see that it deleted the old one, which was some kind of random name that Kubernetes generated, and it created a new one which we are fully in charge. And if you go to properties of that, you will see that this is the static IP address. So no matter what, it will stay static. But of course, Azure charges some money for that. It's not a big money, but still, it's kind of. But with this money, you will get a lot of more proof that it will stay like this. Yeah, now it's already allocated to a new IP address. Let's try to pull it. Yes, now it works from that new IP address. But basically, what you normally want to do is protect the API with SSL, with HTTPS, and for that, usually I was creating the Azure, the Kubernetes ingress control, Nginx ingress control that can accept SSL or something like this. But we can do it more simple. What we can do is to copy that IP address and allocate it as a backend pool for gateway. So this is the special resource in Azure, which is called application gateway, that protects whatever you set behind it from DDoS attacks. It can apply SSL routing. It can apply HTTP as some smart routing. So, but we will use it only for protecting, like, okay, now we have this gateway as a main access point towards our API, public IP address. So here, in backend pools, we have this only one default backend pool, which basically which basically would map gateway IP address towards our API IP address. And you see that it has some web firewall rules, some HTTP settings, some IP configuration, some listeners. Yeah, so what we are having now here, if I copy that, this is the front public IP address of a gateway. So that when I give API to customers, I don't give them public IP of cluster that was generated. I give them that IP address. Let me now paste it here. Oops, did I copy it? Yes. And I would not use the public IP. I would use the DNS name. Kubernetes Meetup demo IP, West Europe Cloud, azurewebsites.com. And you see now it mapped towards our public IP address. And now the tricky part is, and the most interesting part, now you have both your public IP that Kubernetes provided, plus the gateway IP, which is yourself, protected with firewall. I didn't apply SSL, because you need to have a domain name, you need to get a certificate, you need to then upload here in application gateway, you need to upload certificate, you need to kind of make sure that it works, and then you will have the SSL protection. But the last step I want to do is I want to close the Kubernetes IP from the external world, so no one can access it. Because nowadays it takes 4 hours to scan the internet for IP addresses, to get the ports, what they open it, to make a hack, to make some attacks. I want that my application gateway take care of those attacks, not the cluster itself. And the last thing I want to have here is when I go to my IP address, which is Kubernetes IP address, and when I go to, no, sorry, not here. Kubernetes creates so-called network security group, which is in Azure, the place where you specify who can access what IP address, in what port, etc., etc. And if I go here, in inbound rules, I would see that strange name that generated randomly that is routing traffic from internet to my IP address. And I want to protect that. So I want to say that now it says internet, so anyone can access it. But I want to protect it so that only the Azure itself can access it. Only what is within the Azure network can access that IP address, but whatever is outside, all the IP address which is outside world cannot access it. So I would select that, scroll down. Huh? So here, Azure Cloud. And I want to limit that only Azure Cloud West Europe, because I have this cluster set up in West Europe. So I tell now this rule that whoever tries to access this IP address should be hosted in that Azure West Europe region. Probably it's not the best option. Probably we want to only limit to that specifically application gateway. But I didn't have much time to figure out like what to do, how to allocate exactly that resource to allow access to IP address, but all the others not. But if I save now, it will update. It might take a minute, or usually it takes like 5-10 seconds, yeah. And here, I still can access it through application gateway, but if I am, as an internet hacker, try to access it, it probably should be already closed, but it's not. So let's, yeah. It Kubernetes just cache. Maybe if I copy it here, or maybe it usually takes some time to kind of understand the rules. But if I go to incognito mode, paste it here. Yeah, now it's already closed from the outside world. So this public IP address that is generated by Kubernetes is closed. And let me try to copy the one that should be opened, mapped to app gateway. This one is working, yeah. So that's the last thing I want to finalize. Let me play it. Here, yeah. So that's the last thing I wanted to show you, and I hope that now we spent about 20 minutes to set up the API cluster, IP address, some basic protection from the hackers and from the DDoS attacks. And with that kind of architecture, we didn't really pay attention on DNS names yet, or SSL certificates, but you can do it yourself. And I would strongly recommend you I would share this link with the organizers, so you can then access this presentation online. I made it with Microsoft online presentation tool, so that you can then go to GitHub and check README file. And if I miss something, you can then ask me questions. Did I send, my email, basically? Yes.
You can also
And you can share.
You can comment in a meetup group.
Yeah, I will then send my email to there, so you can ask questions if you want. But that was the mostly technical presentation for technical people. I'm not a sales guy, so I'm not selling clusters here. I'm only showing you how we use it, and maybe you find it also useful for you, at least to try Kubernetes in Azure. And the price for the cluster I set up with one node is basically only 50 euros per month. It's I think it's 80 euros per month. 7 gigabyte of RAM plus I think it's 2-core virtual machine there. Only one working node. So this working node will allow you to run like dozens of APIs if they're not so big. But the same approach, the same architecture we use now in production for our smart vending machines. So probably it will grow. We will see if we need to move it to on-premise or if we will continue running this in Azure forever. So far, the experience with AKS, Azure Kubernetes Service, was quite positive. No problems, no issues, no any, only happiness. Yeah. On these notes, thanks a lot for listening, and I hope you will be also try it yourself. Thank you.
Yes, thank you very much.
No questions?
Yeah, if you have any questions.
Yeah, I wanted to ask one thing. Like, would you be able actually to do the same stuff with if you would have a like Kubernetes provisioned on top of virtual network?
Yeah.
And then in the application gateway as a backend pool, just use a private IP address and not a public one. So then you kind of don't need to.
Because actually application gateway, when you instantiate it, it asks you for virtual network that it should be connected. Of course, I was really quickly preparing this demo, so I didn't pay much attention. I think it's possible to pick up the same virtual network you want from the Kubernetes, and then it will be accessing them from the internal ports.
Yeah.
And then, of course, maybe I'm not stating, but maybe it would be even that you don't have to set up a service as a load balancer. You only set it up as a cluster IP. So then you will be using internal IP of the cluster to connect the backend pool with this.
Yeah.
But this needs to be tested. I didn't try it like this.
Yeah, I mean, I haven't used it with API gateway specifically, but usually if you provision with the internal IP addresses, the private, then you don't have a problem of blocking them from the internet.
Yeah. That was, of course, maybe not really the perfect architecture demo, but still something. Yeah. No more questions. Yeah.
Okay, thanks. In developer perspective, what's your take? Do you recommend developing directly to the Azure cloud, or would you prefer like having your own Kubernetes cluster and then debugging on that?
Well, we have always develop and debug in cluster, which is of course smaller size. In Azure, I mean cluster, and then deploy the production to a little bit bigger Kubernetes cluster. So we have two clusters actually: quality assurance cluster plus the production cluster. But we develop mostly we are developing and debugging locally on the laptops, even without clusters. So digital twin, you debug it in one console window, then you have API in another console window. You have the Docker running locally on the laptop, so it's kind of all in one. But then we trust the Kubernetes only for all of these kind of hosting the pods, services, all of this stuff.
Thanks.
Thanks.
Can I ask maybe one more?
Yeah.
One more.
Yes. You didn't open up about like what I'll be interested just to hear if you can mention what do you use with a Kubernetes inside, like service mesh, Istio, any services, like what kind of technologies are like that your microservices are kind of running with on the Kubernetes? Do you use namespaces or?
No, we don't use anything like this. As I said, we only started using Kubernetes maybe 4 months ago. So probably we're not so far with the setup that you are mentioning now. But what we are using is only, basically we have a Docker container, Azure private registry Docker containers there. Then we create a deployment YAML, publish it there to Kubernetes, open up API. And then the containers, they are communicating with the thing called nuts, I think. No, with this nuts messaging system. So I'm not so deeply, how would I say, we're not so deeply using these Kubernetes features. It's only basically only maybe 10 containers we're running there so far.
Oh yeah, thank you. That was the last.
Yeah.
Thank you. Okay, I guess food is ready. So we have a little break. 20 minutes, half an hour, like that.
Something like that. Where
Snack table. Shame on you.
Shame, yes.
we can have one.
Okay, we're gonna, yeah, this, we have to have it. I guess you can put it here on the table.
What's
I was checking your GitHub page and there's one guy that refers that one was testing actually that guy. I know he talked with you and he made like they have like this really small Linux hydro yeah, and he made it right. The thing is like they often take care of I took one and I make my master and if I have a Raspberry Pi like this and I'm like sending one just to make my Raspberry Pi and I'm thinking okay, so if I make that Raspberry Pi like a working and I make this like node selector so that only that Raspberry Pi for some reason the doesn't stage on the port. Master works, my API works, but in that Raspberry Pi it doesn't start. Yeah, so if have you set it both on the node? Have you labeled the node? Yes, I labeled the node. Yes. But the thing is like I'm using this to sell it. Then I think like I don't know to sell the so you're using AMD for the master? Yes. Then you don't have network issue. I have the panel working. I deploy this Nginx port and that works in master and in the worker and everything works very nice. But my API that has the library, well, the one that switches the coffee machine is this resources framework, and it has this the library in Python to send the signal to the. Well, basically, the question in your cluster setup with the Linux version that they use, you can turn off like I/O because that's the only difference that I'm trying to switch. Because for example, you don't need today you don't need to use today it's mainline in the kernel. Okay. That was the weird thing that I tried to deploy only the Docker image or execute any Python code, but it doesn't switch. And I have another Raspberry Pi with this sense hat stuff, and I installed the Raspberry, and it works. So I guess there is no Ubuntu kind of connection with the I/O. If you need to enable some device in Docker, you need to find the device that, like I think so like KVM and many other char device, which can't just be volume mounted in. Okay. Then you might need to do Docker run dash device.
the container binding.
Is the container binding, okay. And then after that I can try to run it in the, so the worker node in Kubernetes can trigger that. Yeah, okay, that was the main.
anything on the screen, or is it, I'm blind?
The screen isn't on.
I just turned it on, maybe it takes a while to...
It takes a while.
Okay.
It should like warm
Yeah,
up.
now,
Then put the mic on.
All right.
It should warm up in a second.
All right. All right. Thanks everyone for being here. My name is Carol Chen, and I have to say I'm a little bit nervous because even though it's not the first time I'm speaking, it's my first time speaking at the Kubernetes meetup. So, and I'm sure most of you have much more experience in Kubernetes than I do. So, and I have to say, like the first time, it was just a couple of weeks ago that I installed Minikube. So, you know, I'm like that much of a newbie. And you know, started playing with the kubectl commands and stuff like that. So today's talk will be not very technical. So sorry if you're expecting that. Hopefully, in future events, I'll be able to share a bit more interesting technical stuff as I learn them myself. So, so again, my name is Carol Chen, as I mentioned. I work for Red Hat. And oops, I'm still using the old logo slides. I need to update that. We had a new logo recently. I'm a community architect. What that means is I work with a developer community for different upstream projects. And my main projects are Managed IQ, which is the upstream for Red Hat's CloudForms product, and the Ansible, which is Ansible. So. That's why I'm using the Ansible slides here. And you can find me on different social or GitHub or even on IRC, as well as Slack. I'm on the Kubernetes Slack as Cybat. All right. So I'll start off with a round of acknowledgements. First of all, thanks to Oliver for inviting me. And I heard that you've been doing a great job getting people involved in these things. And because I myself do a lot of meetups, so I know the kind of effort and work that goes into that. So thanks and much appreciated. And thanks to Futurize for sponsoring the space and the refreshments. I really appreciate that a lot because I just live like 5 minutes walk across the road from here. I actually had a meeting till 5. I was like, do I need to postpone it or change it, reschedule it? It's like, nah, I can get here in time. But of course, you know, Murphy's Law, that meeting ran over time and I was a bit late. But anyway, so thankfully I didn't have to trek across town to come to the meetup. And of course, without good content and people who are here to share and enjoy the content with other speakers and the attendees, there's no meetup. So thanks to everyone for that. And you can tell that I'm used to doing meetups because I have this slide usually on my second slide of my presentation. So that's that. I'd like to share my experiences at KubeCon. Who was in Barcelona end of last month for KubeCon? All right. Oh, 4 of us. Okay, 5 of us. Good to see you again, I guess. Yeah, for me, even though I'm not a first timer to large events, I was pleasantly surprised by not just like the number of people. This is like 10 seconds before they let the crowd in, and Red Hat booth was like somewhere here, so that I took that picture. Like, I could feel like the the excitement, the energy in the air. Maybe the picture does not show it that well, but it's very tangible. So I was pleasantly surprised by not just the number of people who are interested in Kubernetes and attending such events, but also the interest, the excitement, and the kind of passion and desire to learn and share about this technology. So overall, my first KubeCon experience is very positive, and it's been, the community has been growing pretty exponentially, I think. I'm sure Lucas or somebody has more concrete numbers, but I heard like every KubeCon gets bigger, and every activity gets more, more people signing up, and it's just there's just so much going on. So my part attending it, partly to, of course, learn about Kubernetes, partly also I attended some kind of more intro, beginner level technical talks, but also some community-related talks to really learn about how you interact and manage such a large, growing community. And there's definitely a lot to learn and share with each other. So, yep, lots of people. And then lots of lines to the talks, lines to the sessions, lines up the escalator, and lines to the restroom. And as much as, we talk about having great crowds and kind of interest, there is the little downside to this, which is not particular just to KubeCon, but many technical events in general, is you see this is it's actually, there's one door to both the gents and the ladies. The lines for the gents. There was no line to the ladies, which is, good for me. I didn't have to wait in line, and I had a whole bathroom to myself. But it's bad for the industry and community as a whole. So, and I promised myself that at every event I go to, I will speak a little bit about diversity and inclusion. Not a whole talk. I just want to mention, because I think it's not just like going to one talk at an event to hear about it. It's something that we should do constantly and consistently to make a difference. So I did go to the inclusion and diversity talk. This is the panel at KubeCon. So already pretty positive to see that there's a nice balance of gender ratio on the stage. So great start. But actually, as one of the panelists mentioned themselves, that they looked around and say, well, it's good that we have both male and female, but the whole panel is pretty white. So, of course, it's a Barcelona event, so, like most people are from Europe and, and so on and so forth. But there are other ethnicities and people, even in Europe in general, so it's not like a good excuse, so to speak. So, what can we do about it? I'm glad to say that at least today I'm not the only female in the meetup, which happens quite a lot, I'm sure. And I think in general, Finland and the Nordics is quite good about being inclusive and diverse. I've attended events here in Finland like Future Female, Nice Tuesday, Women in Tech, which are focused on giving more opportunities to women. And when you go to such events, you see like, hey, 80% women. Where are they all hiding? They're around. We have a lot of women in the industry. Why don't you see them on stage, on keynote stages, at events and things like that? So, what can we do? I have an assignment for everyone. The next time you sign up for a meetup on meetup.com or anything, extend the invitation to somebody who identifies as a different gender than you, or who is a different ethnicity or background than you, or even different generation than you. Like, I'm Gen X. Most of the events nowadays are, okay, I don't want to put labels, but, just as a generic kind of identification. Millennials and, maybe there are some baby boomers around, I don't know. But I used to organize more events in Tampere. And, for like in the last 5-6 years ago. And you see the similar group of people attending different events. But nowadays, I don't see the same group of people anymore. Of course, new people come in, old people. The previous group might, find some other interest. But I'm actually one of those older people who sometimes I wonder, where are the people I used to associate with? What are they doing nowadays? What's not welcoming in these new events for them? Is it the technology has changed? Or is it that it's just now so filled with young people that, they feel a bit out of place or whatever? So it's not about we need, how many percentage of old versus young, male versus female. It's just about making sure that this is available to everyone. So yeah, like I said, next time you know of an event, just extend the invitation to somebody who looks a little bit different than yourself. I think that's that, step by step we can make a difference. And it's really great to hear from different backgrounds and different people. That's how you learn from each other. So, and that's how I learn anyway. So that's that. And like I said, I had a really great time, and I'm actually going to KubeCon in Shanghai in 2 weeks. Anybody going there? All right, good. Are you going, Lucas?
Actually, this is the first KubeCon.
Oh no. Oh, okay, that's true. I have to fly on Johannes, so that's the downside. But I'm sure I'll see a very different crowd there. It's actually KubeCon with Cloud Native Con plus Open Source Summit, like 3 events in one or something. I was in Open Source Summit Beijing last year, and I have to say, of course, I would say 80%, 90% are Asians or Chinese or something. But I was actually a little bit disappointed to see more than half the keynotes represented by white male. Nothing against you white males, I love you all. But we're in an Asian country, we're in an Asian event. Why is it that, why is that, And you start to question, like, why not give more opportunities to somebody who's a little bit different and who has a different perspective? And yeah, let's see, maybe it'll be different this time. I hope to be pleasantly surprised. All right. So this is kind of introducing, it's something new to me. Like I said, I'm new to Kubernetes. I'm very new to operators. Who knows what operators are? Oh, that's a good number. That's good. Who have written an operator? You've attended the workshop, so that's good. Yeah, so with Red Hat, Red Hat supported, but it's really a community-based thing. There's this new operator framework, which supports the development of operators in a much kind of more, how to say, not guided, but in a easier way and a structured way. Yes, let's put it that way. So what the operator framework supports is 3 ways of writing operators. Using Go, which, because Kubernetes is based on Go and it's a natural language for Kubernetes developers. Then again, a lot of people who are Kubernetes users may not have actual Go development experience. Who actually develops stuff in Go, for example? Oh, actually, quite a good number. That's cool. Who is familiar or uses Ansible? Oh, I'm glad to see quite a number of hands, because the operator framework supports Go, like I mentioned, Helm charts, as well as using Ansible. Oh, Helm, cool. As well as Ansible to develop write operators for Kubernetes. So, and Ansible is based in YAML, and a lot of the Kubernetes stuff, workflow is also YAML-based. So that's actually a simple, very kind of direct way of mapping some of these playbooks and roles into operators so that you can deploy them on Kubernetes. So I actually went through this whole workshop myself a couple of weeks ago, and I started dreaming in YAML. So if that doesn't sound like a nightmare to you, consider using Ansible. So one last question. If I, either myself or maybe a colleague of mine conduct a operators framework workshop with a focus on Ansible, who will be interested? Okay. Oh, good to know. Yeah, because as a workshop is more involved, maybe we can discuss that possibility. We will need a bigger space with like people who would need to work on their laptops and so on and so forth. But Anton, you mentioned that you were in Barcelona and attended the workshop as well. So I remember it's not Ansible focused though, because that's my specialty. But they did go through all 3, yeah. Right, Golang is the focus. Right. Exactly, yeah. So for me, if I were to give the workshop, because I know Ansible much better than anything Go related, so my focus would be different, but I could probably get somebody to cover the Go part of things. So, all right, that's great. And just to introduce, yeah, so there's this operator framework. You can already start looking at it if you are interested. github.com/operator-framework. And the operator hub is where people can contribute. Excuse me. Again, this is, yeah, I don't think we even have, it's just, some people say, oh, is it like OpenShift specific because OpenShift is a Red Hat product? No, it's not. It's, all of this runs on Kubernetes. So it's all open and community related. Oops, where's my, okay. All right. And today I won't be going into the details much, but suffice to say, I'm glad there's interest, and maybe we can do more the next time around. And as I work for the Ansible side, I kind of have to plug a little bit about events. We have Ansible Fest coming up. It's based in the US, but it's end of September in Atlanta. We have been pushing for Ansible Fest in Europe for quite a bit, so we hope to see that happening next year. And then meetups. We actually have quite an active Helsinki meetup group. And as usual, I myself I'm based in Tampere. Like I said, I live across the street, 5 minutes away. So is there any interest to have a more dedicated Ansible meetup group? Everybody's so loyal to the Kubernetes. Well, that's fine. I might just attend this meetup and share more Ansible Kubernetes related stuff, and that's perfectly fine with me, because it does take effort to organize a group, and sometimes it's great that we can support each other, the different communities. So, and that's all I have. I don't have that much details, but I welcome any questions, comments, criticisms. By the way, yes, I almost forgot. The Slack table, I do have, Ansible stickers, of course. Kubernetes temporary tattoos. I don't have stickers for some reason, but I have temporary tattoos. So operator framework stickers and okd.io. OKD is the upstream for the Red Hat OpenShift product. So if you go to okd.io, there's the open source side of things. You can try things out. You can download things, break things, whatever. If you break things, you keep all the pieces, as they always say. So feel free to check them out. That's all from me. Thank you very much.
Thank you. I'm thinking. Yes. Without planning this at all, I'm going to build on top of what Carol said. And it was a great presentation, and I like the theme. And I'm going to expand on this a bit more, on what we do from CNCF side and Kubernetes side too, to achieve this kind of thing. There we go. So I had my first keynote I've been speaking at multiple KubeCons before, but I had my first keynote now in Barcelona. There were, I don't know if you mentioned it, but it's 8,000 around this time. It's grown really fast. 2 years ago in Seattle, it was 1,000. Then we came to Europe, 1,500. Then Austin, 4,300. Copenhagen a year ago, 4,500. Shanghai, 2,000. The first one in Shanghai was last year, 2,500. It was a really good start, and will be way more now when you go. And then boom, 8,000 in Seattle in December, and now around 8,000 too in Barcelona. And I'm going to skip that part and go directly to this. This is about Kubernetes contributors, but the same thing goes for KubeCon. And it grows really fast. We see that when Google, nearly a year after Google announced this thing, it was still like in the range of 400 something contributors. And here a contributor is someone who's committed something, who's created an issue, PR, different kinds of interactions with the repo. And what we say here, so I have to say that too. I made this presentation together with Nikita from India. She's a university graduate from a university there, and now works remotely from India to a software company in Europe as a freelancer. And we started thinking about this in the same pattern. When we have a group growing this rapidly, what do we need? What is key to actually be able to continue this so everything doesn't fall apart? Well, the key is values. So we have to have, in order to maintain this kind of cultural change, we have to have a really strong ground in the community values. And Sarah Novotny, who was really building this community from the get-go, and the rest of the Kubernetes team formalized 5 different values for the Kubernetes community, and this holds true to the rest of CNCF projects too, and is at core there. So first, inclusion is core to us. And do we have any numbers why it's core to us? Yes, we do. And for example, we have the diversity scholarships. I'm going to talk about a bit more about that later. My first KubeCon, for example, I got a diversity scholarship. Nikita's first KubeCon, she got a diversity scholarship. The director of CNCF, director of ecosystem at CNCF, her first KubeCon was a diversity scholarship, etc., etc., etc. There's loads of examples because we have had 300 such people. And CNCF and other sponsors have spent over $770 just flying people from all around the globe to KubeCon events. And this is a huge thing, and it matters a lot. We have to, in order to keep this all together and have a successful project, we need different perspectives, different skill sets that only can be found in different places of the world, and different genders, different ages, everything. And we do other stuff too. So we also address that there's knowledge, differences in knowledge and what knowledge you can have. So knowledge diversity is a thing too. That's why we have different onboarding events. We have different mentoring. We have diversity lunches where you can come pair program if you want, discuss important matters, stuff like that. So a couple of keystones. Anyone is welcome. We show respect for the time and effort put into contributions. And if you do contribute a lot, again, this is we say this for Kubernetes because us to kind of represent and talk about what it's in the Kubernetes community, but this holds true pretty much for the CNCF projects as a whole. So leadership is earned through quantity, quality, and duration of contributions. But it's important to remember that respect belongs to everybody. And then we have this, community of a company. And what do we mean with this? We mean that by having a solid core, and that is rock solid and open, and companies making this better, improving security, stability, interoperability, and so on and so forth, their effort that they made one time, these contributors' effort that they make one time to the core, the impact is multiplied across like thousands and 10,000s of installations out there. So it doesn't end up in this one commercial company's proprietary fork. And also, reputation comes from contributions for companies too. And individuals, as earlier said, can gain status through their work with regards to, for example, merging rights and such things. And what makes this all work in the end is also this kind of thing that Sarah Novotny says here. That having really strong community values and having a group of people working from totally different companies that identify as community members before their affiliation is what makes stuff actually work. And this goes true for myself. I did not, so far at least, tell you who my main client is. Because for my main client, I do Kubernetes upstream work. So another thing is people switch companies all the time. Sarah worked for Google, now she's moving to another company. A lot of people joined Heptio, which is now VMware, but it all just is exactly the same from a community perspective. Companies that their investments are also rewarded by stuff like this. Recognition for the things they actually do in the broader ecosystem, in media, or in CNCF project DevStats, which tracks actual numbers of who has contributed, who is actually there doing the important stuff. And here we grow the next generation of leadership through mentorship, through shadowing, and in other key areas. So for example, code ownership is close to those who know it. And if you contribute to an area specifically, you gradually become an owner of that part. So we have every cycle, which is 3 months, every release. At the end of the cycle, we look at who's been doing good work this cycle and promote them up the ladder. And shadowing means that, for example, in the release team, is a best example here, that the release team has different positions. Somebody's concerned with maybe stability, someone is docs, someone is what features go in there, someone is the lead, whatever, etc. But anyone can also shadow these people. So basically look at what they're doing, help them when they're doing something, but doesn't have the full responsibility of getting it done, but can follow here, give input. And this is one of the most important things in this whole system. It's a thing that, again, Saran Novotny made, coined for this community, and that's chop wood, carry water. In other words, do the really important but boring work. The stuff that just needs to get done to make it all function. And it was, that's so important, so CNCF even created an award just for that, giving them actually a piece of wood. For the efforts in the community, working on the stuff that actually matters, without doing shiny new features or really big announcements on the latest stuff, just making it possible to have this kind of project. And the last part I'm going to talk about is that if we don't have a good culture, it makes no, so we have, for example, the steering committee, we have different top-level owners, we have different kinds of people, to some extent leading, but there's of no worth having somebody say, well, we should go this direction if everybody just competes all the time and can't agree on anything. Then it doesn't matter what we say we're going to deliver in 2019 if we don't have people willing to succeed. So culture is whatever strategy that we have. So yes, that's that part. It was a longer talk. Also, looking into what how you, if you now want to start contribute, how you can do so. This video is called Getting Started in the Kubernetes Community. I can even share it afterwards. There's a YouTube recording up, but we don't have time to do the rest of the talk. But it was a great talk here before, and I wanted to build on top of that spontaneously. Thank you. There we go. Cheers.
Damn. Is it good now?
Yes.
Thanks. One moment. There we go. Thanks. I need a dongle because I have a MacBook. Yeah, it's great to be here, talking about a subject that I'm really interested in, and yeah, thanks for Carol and Sergey for their great talks. I think it's really cool that you guys talk about diversity and inclusion, because that's important. That's way more important than Kubernetes or computers, you know. So now I'm kind of sad that I don't have anything about that in my presentation. Instead, I'm talking about, you know, computers or serverless. Let's see if I get this working. There we go. But yeah. I'm talking about serverless in a Kubernetes meetup. What the hell? I had this talk about a month ago, and then I got asked to have a talk here too, and I was too lazy to make a new talk, so we'll stick with this one. But as it turns out, serverless is actually kind of like really related to Kubernetes and the kind of like the ideas behind Kubernetes, and there's serverless things built on top of Kubernetes. So yeah, in my talk, we'll take kind of like this wide look into serverless. Not that much about what it is, but maybe a bit about my experiences with it, and how does it compare with, let's say, like traditional computing, and how it fits in the larger picture of, let's say, DevOps, for example. And then also a bit about what the future might hold for serverless. And And yeah, if you guys got any questions at any point, just raise your hand, and yeah, go ahead. A bit about me. I work currently at Futurist as a full stack dev and a cloud architect kind of person. And yeah, I'm AWS certified, so anything I say here is true. I've had a bunch of experiences using serverless technologies at work. I've been doing like 3 projects at Futures and before Futures also with AWS Lambdas and stuff like that. The first one was we were creating this like migrating a legacy backend partly into AWS Lambdas with Node.js, and we were creating some new features on top of that. Then the second project was like this big retailer marketing tool with some heavy SAP integrations and shit. So we built the integrations with Lambdas, which were like these once-a-day fetches workers, which fetched some stuff from SAP into our database and stuff like that. And the third project was a big vehicle leasing platform where we built the whole backend with AWS Lambdas, and that turned out to be quite nice, actually. And yeah, in the first project, we were using a serverless framework. In the second one, we were just using Terraform, and in the third one, we were using a combination of both. And that worked out pretty well, actually. And yeah, the third project was when I was living in London, and we were working for this like big car manufacturing company, and we had a ton of problems in the project, like with the contracts, and then we had to wait for integrations for half a year, which should have been there from day one, and then our freaking roof was leaking on our tables, so we lost our like keyboards and shit. But at least our backend scaled, so there's that. But yeah. Now that I've been using, these serverless technologies for a couple of years at work, I've been kind of like learning about what they are and where you should use them and where you maybe shouldn't, and what's the current state of them. And I'm going to first approach this from like this functions as a service point of view. And often when people talk about serverless, they talk about functions as a service, but that's not, I think, what it's limited to. There's a lot more to it. Yeah, but let's first take kind of like this look into the different options we have when we start looking into serverless, and if we are interested in it and want to use it. There's the three usual suspects. So there's AWS Lambdas and Azure Functions and Google Cloud Functions, which can be, I guess, grouped as like functions as service. I think that like IBM has their own in Bluemix and stuff like that, but who wants to use that anyway? Then there's stuff like we have like Netlify and Now, which kind of like abstract these three into their own kind of like layer, you could say, and they add some features on top of it, which makes it easier to manage it, at least on paper. But yeah, there's a lot of tools to choose from when you go functions as a service. But in addition to functions as a service, there's stuff like AWS Fargate and Google Kubernetes Engine, which you guys are probably more interested in, which have like, you could say, serverless functionalities or thoughts taken from the serverless world into the container world. And then there's stuff like Aurora and DynamoDB, which are serverless databases. And then there's weird things like AWS Amplify, which is like full stack serverless, so you can build your whole application in a serverless way. But yeah, let's look at the functions as a service at first, because that's what I've been like using for building my backends in the projects. Like with all things, there's some good and bad sides to it if you decide to build your backend on functions as a service. Some of the good things are, well, the two main selling points you see are that it's auto-scaling and it's cheap. Well, yeah, it is, and that's great. But that's not really the best part about it. There's some other really cool things too. Like, for example, it simplifies your infrastructure and it simplifies your deployment. At least it can if you build it well. And that can be really valuable for your team. So, for example, instead of having to manage your EC2 servers, you kind of like push your code in the cloud and then it just runs. Then you can just call it. Functions as service are event-based. What the hell does that mean? It means that it can be triggered, your code can be triggered by other things than just HTTP calls, for example. So you can, for example, write a Lambda function which gets called when an object gets uploaded into your cloud. Or you could write a function that gets triggered when something is inserted into your database or when something is inserted into your queue. You don't have to write like this own layer for handling all of that logic. You can just have it trigger an event and have that event trigger a Lambda function, which does something. And yeah, one other thing that's really cool, when you write your backend on serverless or functions as service, it kind of like forces you and forces the team to think about the architecture you're doing. Because, well, yeah, I'll get a bit deeper into that soon. But yeah, one more thing that's really great is that it's easy and fast to get started with them. So maybe if you've written your servers in a more traditional way before and deployed them, you might take, an hour just provisioning the server and so on. But with Lambdas, if you pick the correct tools, you can get started in like 5 minutes or 10 minutes and have something running on the public internet. But yeah, like I said, there's also bad things. I'll just have a sip of water though first. But yeah, there's a lot of bad things when you think about serverless, and a lot of them are related to the maturity of the technology, I think. So one of the big problems is that there's really no standard practices yet for doing things. So it's unclear when you start building your application how you want to do, for example, code sharing or how you want to build your architecture when you're building your application on Lambdas. And there's not much like information about it online yet. And another thing that's related to that is that there's kind of like a lack of tooling maturity, and a lot of the tooling you face when you want to pick the right tools for building your application, they can be lacking features that you want to have there, or then just buggy. And in addition to those things, there's still a lot of like limits and these things that you just need to know when you work with functions service technologies. There's like there's hardware limits, and then there's kind of like software limits in a way. There's limits like the cold starts you might have heard of sometimes. There's limits to package sizes, so how large your source code package can be. At maximum, it's like 50 megabytes or something. So you might run into problems when you're using a ton of libraries or something. There's hardware limits, so there's limits to the CPU and memory the Lambda function can have. And then there's limits to like the programming languages you can use with these. So at least there's like Node.js, Python, Go, Ruby, but then if you want to go something a bit more wild, then there might just not be support for it. And the worst thing about these limits are that they're often badly documented, and you just kind of like run into them as you do things, instead of like already having the knowledge and then knowing that there's a certain limit. And going back to this forces architecture decisions. That's of course a good thing, because we have to think about our architecture if we want to build it well. But the bad thing is that it forces a microservice architecture. And even though people talk about, microservices are the way to go, but it's not always that simple. Microservices can be good, but it might not be perfect for your application. But yeah, now that you understand the benefits and the bad things about Lambdas or functions as a service, and you still kind of are interested in it, and you think that it might be useful to you, there's a bunch of questions that you can ask yourself to make you understand if you should build your application on them or not. So one is, like I said, well, do I want a microservice architecture? Because that's what you're going to have. Do I get cost savings? You might, but you might not even need them. But yeah, Lambdas are super cheap. You get 1 million requests at least for free, and probably some cents after that for 1 million requests. Yeah, another thing, do I get scaling benefits? Again, you might need them, you might not need them. Are my services good for functions service? It depends. Some things are easier to build on functions service, like these workers and tasks, scheduled jobs, stuff like that. But then maybe traditional these traditional RESTful APIs might be easier to do on like this, for example, Docker container or whatever.
Sorry, I'm gonna have to go. The train leaves at 8 p.m. But thank you for attending, and see you next time.
Thanks for organizing. Then we get to the perhaps even the more important questions. The people matters. Is my team ready for it? So does my team have the necessary knowledge to be able to build their application on serverless? And also, is my infrastructure and DevOps ready for it? If you're already using a cloud provider like AWS or Azure or whatever, then it's easy to take functions services into use. But if you have on-prem stuff a lot and so on, it might be a bit harder. And yeah, like I said, there's technical limitations, so you've got to be sure that you're fine with those. But anyways, it doesn't really matter which of these cloud providers you use, the 3 big ones that I listed, for example. I think the most important thing is that you don't want to manage your infrastructure by hand, because it's already 2019. If you're doing it, you're living in the past, I think. So instead, you want to use tools like, for example, Serverless Framework or AWS SAM or Now to have your infrastructure as code and have it deploy from the CI. Or you can use stuff like Terraform if you have something else than just functions service. And you probably want to use Terraform because serverless is very serverless specific. But yeah, like I said, don't click around on the AWS UI. Just have your infrastructure as code in the version control. But yeah, when I think about serverless, I kind of see it as just part of a bigger picture or part of a bigger continuum of DevOps and how things have been going in the hosting world for the past, I don't know, well, ever since it existed, actually, when you think about it. Well, you've all heard the word DevOps. What is it about? It's about developers not needing to spend time with infrastructure and deployment. It's about developers spending their time with code and having it easily being able to easily deploy it and ship it. Because in the end, that's what developers are hired to do. They're hired to write business logic, not not to spend their time with the infrastructure. So yeah, I just see serverless as this like natural step in DevOps thinking. So when you think about the past, we first had on-premise stuff where everything, the hardware included, was self-managed. And so we bought the hardware, we installed it ourselves, and that took a ton of time. Then we got cloud, which is huge, of course, where the servers and the hardware is provided. And now we just need to think about provisioning and scaling stuff and pushing our code into the cloud to run it. But now we got serverless, where everything is provided for you, so you only need to think about code. You only need to think about business logic. That's awesome. But, well, that's pretty far from the truth at the moment. There's still a ton of things you need to think about. There's like serverless-specific tooling you have to use, serverless-specific configurations, limits, networking, and that sucks. You know, I just wanna write my code and push it into the internet and have it run easily. So how the hell do we get from this socket serverless to serverless 2.0, what I call it? And yeah, I don't have the rights to use the Half-Life logo, but yeah. So yeah, it's a really good question how we're actually gonna get there, and I'm just best guessing at the moment. But I kind of like feel like that these stuff like this, the Google Kubernetes engine and AWS Fargate, and maybe Azure has its own, well, like Sergey talked, Azure has something like it at least. I think they're really taking the correct approach to it, because when you write your containers, you don't really need to think about the platform you're running it on. You just run Docker containers or write Docker containers, and it doesn't matter which technologies you're using underneath. It just works if you make it work. So yeah, it's awesome. It's your containers instead of these AWS Lambdas, which are like black boxes you don't get access to. So it's your containers, and that makes it technology agnostic. So you can pick what technology you're using instead of being limited. And well, I say here that there's no limits, but of course there's limits on AWS servers and Azure servers or Google servers. Of course there's limits, but they're not like that restricting as they are in Lambdas. So yeah, like I said, there's nothing serverless specific. And even when you think when you read about like this AWS description of the Fargate system, it says Fargate lets you focus on designing and building your application instead of managing the infrastructure that runs them. I mean, that's what serverless is all about, right? Writing business logic instead of worrying about infrastructure and deployment. So that's awesome. Well, what about these functions as a service stuff? What will happen to them? Are they useless? Well, no, I don't think so. They're still really good for some certain things like, well, like I talked about, they're event-based, which allows you to do some really neat stuff really easily. So, for example, you could maybe have like this object storage, and when an object gets uploaded, then an email gets sent from your Lambda. And that's really easy to do with these function as a service stuff. And then there's other things like certain kinds of workers and tasks. So if you, for example, want to do a scheduled task, so which runs maybe once a day, it's really easy to do it with Lambdas. And maybe some simple backend services, some simple RESTful services, that's absolutely fine. Because like I said, it's super easy to get started with these. You can get something deployed in 10 minutes, and that's awesome. Yeah, there might be something else too. But yeah, that's my talk. Cheers. I tried to be quite quick because we were a bit late on schedule. Do you have any questions?
How do you see this kind of like a lock-in factor with this kind of?
Logging.
kind of lock-in factor. So I mean, if you develop something with like Amazon Lambda, it's probably not going to work out of the box if you run it on Azure.
That's a great point. And so he was asking about vendor locking, basically vendor locking to AWS or vendor locking to Azure when you're writing these functions service stuff, and that's a really good point. And I think that's one of the bigger reasons also why these container services are better. But yeah, it's a problem. But luckily, the differences between these, for example, AWS Lambdas and Google Cloud Functions, it's not very large. I mean, I think it's just maybe a couple of lines of code you need to change. Okay. But then again, there's the issue that if you write your functions service on AWS, you're probably using a lot of AWS services in it. So for example, S3 and stuff. Yeah. And that's then, if you start going into that deeper hole, then it's much harder to change vendors. Yeah, there's a question back there.
So actually this question was for Lucas, but he apparently needed to run away. It was a bit of a mix of your talk and the things that Lucas has been doing. As far as I know, Lucas is one of the original developers of kubeadmin. So I was wondering, would it be possible to rewrite kubeadmin as entirely serverless, since it literally just takes in and sends out commands? So it is, in essence, event-based. As far as I know, I'm not so sure about streams, but they could maybe be chopped up into events.
So yeah, I'm not sure really if approach, but I know that there is a project started at Kubernetes that's called Knative. So that's a serverless platform on top of Kubernetes. So there you can do the standard way, and you don't get a vendor login, I think. I have not done anything with it, but I follow their Slack channel, and they're quite active. So this is a new thing that comes up.
Yeah. And
I don't know, have you experience with Knative?
No, I don't. I don't have. I have experience with Fargate, but that's way more like vendor locking than Knative, I'm sure. But I personally think that Fargate is awesome. I mean, it's just you push your container and then it scales indefinitely, automatically, and I think that's awesome. I mean, that's like serverless containers, but the problem there at the moment is that it still requires a lot of configuration, I think, too much.
Yes, there is a Firecracker. I think it's the technology under Fargate, and then it's open, I think one of the first open source tools of AWS. So that's also Knative and Firecracker. If you're interested in some serverless, something to check out.
Any other questions? All right. Cheers, guys.
Okay, yeah, thanks again for the speakers and attendees. So we are planning to have maybe August the next summer break. And yeah, so we might plan a workshop for August. So yes, welcome again.
There's a thing called kubeless as well. Yeah, I've seen that one and I've used that one, but that's basically running serverless inside your kube contain or like in your cluster. I was thinking about like, okay, kubeadmin literally is just, it's a server that just takes in admin commands and sends out admin commands to the nodes. Why not just do that as entirely serverless and